Hey everybody, we're going to try trig part 2 today. It's the second part of the first section, or section 8.2 notes. So here we go. Today we're actually going to use trig to find the lengths of the side of a right triangle. And as you can remember, we learned how to use Pythagorean theorem, special right triangles, 30, 60, 90, 45, 45, 90, and also geometric mean to find the length of the side of a triangle. And now this is going to be a fourth option. You guys are going to actually really like this option. Okay, so here's the deal. I'm left-handed, so everything has to be turned a little bit. We have this right triangle, and again, most of these should be in your book. And the question is saying, find the length of side AB, right here. Okay, so here's AB. I'm going to show you a couple different ways to do this. First of all, if you notice in your right triangle, you have your right angle, you have 41 degrees, which is the measure of angle A, and you have a blank angle. When we do trig functions, remember, it's sine, cosine, or tangent of a given angle measure. We don't want to worry about taking the sine, cosine, or tangent of 90. This one isn't here. We could figure it out, but why waste our time? So I'm going to circle the angle they give me, which in this case is angle A, 41 degrees. That is going to be my reference angle. Okay, then what I'm going to do is I'm going to label my sides. Okay, so you'll notice that you're looking for the length of side AB. So in my problem, I'm going to call the length of AB X. I'm going to put an X there. And I'm going to label the sides that have the variable and that have the number given to me. So, and I'm going to label them by using either opposite, adjacent, or hypotenuse. Okay, so here's my reference angle. The side straight across from that is 6.1. So this would be straight across is going to be my opposite side. And you'll notice the side that I'm looking for is right here. And that's going to be my adjacent side. I'm going to use a different color for that. I got all my colored pens out. See that? Pretty sweet, huh? Okay. So this is going to be my adjacent side. Right there. And if you remember back, our acronym for trig is SOHCAHTOA. So I'm going to write it right here to remind ourselves. Sine is opposite over hypotenuse. Okay. Adjacent. Cosine, rather, is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you notice, I have my angle, and I am given opposite, and I'm given adjacent. So if you look up here, the trig function that uses opposite and adjacent is tangent. Right, so tangent is opposite over adjacent. So that's what I'm going to do. I'm going to write tangent. And the angle that I'm referenced, the angle that I circled is angle A, which is 41 degrees. So I'm going to put 41 right here, is equal to the side opposite, which is 6.1 degree or 6.1 units, over the adjacent, in this case, is X. And that is my setup. That is how I use my trig function right there. Now you guys know that if you type tangent of 41 into your calculator, you get a crazy decimal. Just like up here when we did these. We rounded these, but of course they were some crazy decimal numbers. So this is just a number. So what I can do is to solve for X, I can put tangent of 41, I can put that over 1, and then I can just cross multiply like what I did back a couple chapters ago. So when you cross multiply this, you get X times the tangent of 41 is equal to 6.1 times 1, which is just 6.1. And since this is times and this represents an actual number, I can just divide both sides by tangent of 41. Okay, those cancel out and I get X equal to, and in my calculator, I will type in, let's see, put my on, 6.1 divided by tangent of 41. Tangent, in parentheses, 41. Enter. 7.02, if I round it. And that's my answer. And x represents the length of this side. Okay. Now in this next example, I'm going to show you a similar way, but some of you might like this one a little bit better. So again, I have my right triangle. You can only use trig with a right triangle. I'm looking for MP right here. So I'm going to label that X because that's easiest. And then again, I'm going to circle the angle they give me, and it's going to be the non-right angle. So I'm going to circle 20 degrees. At this point, based on this reference angle, I'm going to label all of my sides. In the previous example, I only labeled the sides I was using. This one, let's label all the sides because it might be helpful. So straight across from 20, I have a leg, okay, and this is going to be my opposite leg. Obviously, right across from 90 degrees, I have my hypotenuse. And the side right beside the angle is given me, the adjacent side is going to be the adjacent side, or the adjacent leg. Okay, now, again, just like in my previous example, I'm going to only worry about the sides that have either variables or numbers. If you notice, the adjacent leg has nothing, so I don't need this one at all. So I'm going to use the side directly across, so opposite, and the side directly, or the hypotenuse, which is directly across from the 90-degree angle, opposite over hypotenuse. If you look up here, opposite and hypotenuse is sine. So for this particular problem, I'm going to say the sine of the angle, so the sine of 20 is equal to OH. So sine is opposite over hypotenuse, x over 8.7, and that's what I'll write here. X over 8.7. And again, sine of 20 just represents a number, so we can put that over 1 and cross multiply. So this one's a little bit easier. I get x times 1, which is x, equals 8.7 times sine of 20. Be very, very, very careful when you type this into your calculator to put 8.7 first. Because if you put sine of 20 times 8.7, your calculator will multiply 20 and 8.7, then take the sine, and that's wrong. So just put this number first, and you're good to go. So when I type it in my calculator, I type in 8.7 times sine of 20, 2.98. And again, that's the length of the missing side. Okay? There it is. And again, you can find these in your book, and I will also post a Khan Academy video as well. Oh, let's do one more. Let's do this one. Okay? So you have your right triangle, you have the angle they give you, the side they give you, and you're looking for YZ, which is right here. So we'll call that X, little x. Okay, I know the triangle's named XYZ. That could be confusing. You can call it whatever you want. Okay, so I'm going to circle my reference angle, which is 38 degrees, right here. And I'm going to label my sides. Straight across is my opposite, so I'm going to call that O for opposite, or I guess I could put O opposite there. Straight across from 90 is my hypotenuse. And right beside my angle that I have circled is the adjacent. So you'll notice in this problem, the side that's not used, the side that doesn't have a number or variable, is the opposite side. So I don't need that at all. I need to look for a trig function that uses hypotenuse and also uses adjacent. So if you look at your acronym, sine doesn't, tangent, what do I have here? Adjacent and hypotenuse, tangent doesn't. So in this case, it's going to be cosine. Cosine is the adjacent over the hypotenuse. So that's what I'm going to write. Cosine of the angle, in this case, is 38. And remember, that just plops right in there. Equals the leg adjacent, which is 12.6, divided by the hypotenuse, which is x. Put this over 1 and cross multiply, just like before. So we get x cosine of 38 equals 12.6. Divide both sides by cosine of 38. Whoop, there it is. and you get x is approximately, and in my calculator, I'm going to do 12.6 divided by cosine of 38. Again, making sure it's in degrees. See, my calculator's in degrees. 15.99. That's my value of x. Okay, I'm going to stop here because I don't want to overload you with video. Possibly later I might post some more video of the other 4 or 5 examples there. But definitely try these. Look in your book if you need to. I'm going to post that Khan Academy video, so hopefully that'll help. And then you want to definitely try the book assignment. This is a really important lesson. All right, good job today, guys. I miss you so much. You have no idea. All right, talk to you soon. Bye.